I'm Matt.
And I'm Skylar. And let's get physical.
Alright, so we have problem 8.49, which is a 0.1 kilogram ball on a 60 centimeter long string is swung from a vertical circle about a point 200 centimeters above the floor. The string suddenly breaks when it is parallel to the ground and the ball is moving upward. The ball reaches a height 600 centimeters above the floor. What was the tension in the string an instant before it breaks? So we're solving for tension.
Tension. So here's a diagram of the situation. So we have, we converted it all to the standard metric units, and the ball was already in kilograms, so we converted the centimeters into meters. So it goes upwards 4 meters. It's already 2 meters off the ground, and it's the string attached to the ball is 0.6 meters long, as you could see here, here, and here. And yeah, that's just a simple diagram of what's going on. So we're gonna solve for
Tension.
the tension of that string.
So first off, to solve for the tension, you have to find the velocity at which the ball is released at its point horizontal to the ground, perpendicular, whatever it was, parallel to the ground. So we're going to use the third kinematics equation because that's the one that we don't need time and we don't have time here. So the third kinematics equation is a final velocity squared equals initial velocity squared plus 2a times the change in x, or in our case y. And so the final velocity is just when it's at its apex, which is 0. So we have 0 equals initial velocity squared, what we're solving for, plus 2 times negative 9.8 times 4. And the negative 9.8, the acceleration here is just gravity. The 4 being the change in x, or which is the 4 meters it goes up. And so we have 0 equals initial velocity squared minus 78.4. And then so just add 78.4. And that equals initial velocity squared. Square root both of these. And you have a 8.85. And since velocity is just meters per second.
Okay, so now we got to take that initial velocity we found and find the centripetal acceleration. And the equation for centripetal acceleration is just AC equals velocity squared over the radius of the circle that the ball is traveling in. And so we just simply put in that 8.85 that we got in the last equation, put it over the radius that we got in the problem, and then we get 130.538 meters per second squared as the centripetal acceleration.
Alright, so once we have that, the acceleration is, we have to find the net force, which in this case, the net force is this red arrow right here, and it equals the tension, which is this green arrow right here. So essentially when we're solving for net force, we're solving for tension. And the equation for net force is mass times acceleration. And we just solved the acceleration. The centripetal acceleration is what you plug in. And the mass is the 0.1 kilogram ball that they give us at the beginning. So net force equals 0.1 times 130.538 right here. And which just equals 13.0538. And we're just going to round it up by 1 to net force equals 13.1 newtons because it's in newtons. And then so tension equals net force. So the tension equals 13.1 newtons.
And that deserves a yippee-ki-yay.
Yippee-ki-yay. Thanks for watching.
Peace out.
Peace out, Toons.